Preparing for a data analytics at American Express interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you identify duplicate transactions in SQL? I would first define a duplicate using fields such as card account, merchant, amount, transaction date, and authorization code. Then I would group by those attributes and use having count, greater than 1. For near duplicates, I would compare timestamps within a short window and normalize merchant names. I would validate results against known business rules before deleting anything. At American Express, I would preserve the raw data and flag duplicates for investigation because legitimate retries can resemble fraud. While answering, cover duplicate definition logic, transaction keys, group by and having, time window considerations, false positives, data quality validation, and how you would report or safely resolve duplicate records. Question 2. Write a SQL approach to calculate monthly customer spend and month-over-month growth. I would aggregate approved transaction amounts by customer and calendar month, then apply lag over each customer ordered by month. The growth formula is current spend minus prior spend, divided by prior spend, with null handling when the prior value is 0 or absent. I would generate a complete customer month calendar if missing months should represent 0 activity. Finally, I would reconcile aggregated totals with the source ledger before presenting trends to stakeholders. Make sure to cover date truncation, aggregation by customer and month, window functions such as lag, 0 or missing months, division by 0 handling, and validating the result against financial totals. Question 3. How do inner join, left join, and full outer join differ in a customer analytics problem? An inner join keeps only customers and transactions that match, so it is useful when both records are required. A left join preserves every customer, including those without transactions, which supports inactive customer analysis. A full outer join exposes unmatched records on both sides and helps reconcile systems. I always inspect key uniqueness first, because one-to-many joins can inflate spend. I also test null handling and compare row counts before trusting the output. In your answer, explain row preservation, unmatched records, duplicate join keys, null behavior, practical customer and transaction examples, and how incorrect join choices can distort counts or revenue metrics. Question 4. How would you investigate a sudden decline in credit card transaction approvals? I would confirm the decline using a stable approval rate definition and compare it with prior periods. Next, I would segment by product, geography, merchant category, channel, issuer, and decline reason. I would check whether a pipeline or reporting change created the movement before attributing it to customer behavior. Then I would test hypotheses such as fraud rule changes, outages, or unusual merchant activity. I would present impact, confidence, and recommended actions rather than only a chart. Be sure to mention metric definition, segmentation, comparison periods, data pipeline checks, authorization and decline codes, external factors, hypothesis testing, and communicating actionable findings to risk and operations teams. Question 5. What is the difference between where and having in SQL, and when would you use each? Where filters individual rows before grouping, while having filters groups after aggregation. For example, I would use where to keep approved transactions in a date range, then having to retain customers whose total spend exceeds a threshold. Filtering early usually reduces the data processed and improves performance. I also avoid using having for row-level conditions because it obscures intent. After writing the query, I verify that refunds, null amounts, and excluded statuses follow the business definition. Focus on execution logic, row-level versus aggregate filtering, examples using transaction status and customer spend, null behavior, query readability, and performance benefits from filtering early where appropriate. Question 6. How would you use Python to detect and treat missing values in transaction data? I would profile missingness by column, segment, time period, and source system using pandas. Missing merchant category may require a separate unknown class, while a missing transaction amount should usually be quarantined rather than imputed. I would investigate whether gaps are random or concentrated in a channel, because that can indicate a pipeline issue. Any imputation would be documented and compared with a complete case analysis. I would preserve original fields so downstream users can audit the decision. Discuss profiling missingness, distinguishing random from systematic gaps, data types, imputation choices, business meaning, auditability, and validating how treatment affects fraud, spend, or customer-level conclusions. Question 7. Describe how you would build a customer segmentation analysis in Python. I would begin with a business objective, such as identifying customers likely to respond to a rewards offer. I might create recency, frequency, monetary value, product breadth, and payment behavior features, then scale them before clustering. I would compare methods such as k-means and hierarchical clustering, using silhouette scores and business interpretability. After profiling each segment, I would label them in plain language and recommend targeted actions. I would validate whether segments improve campaign response, not merely statistical separation. Make sure to cover objective definition, feature engineering such as recency frequency monetary measures, scaling, clustering choice, validation, interpretability, and converting segments into marketing or servicing actions. Question 8. How would you evaluate whether a customer retention campaign was successful? I would define retention before launch, such as active usage after 90 days, and randomly assign eligible customers to treatment and control groups. I would compare retention rates, incremental lift, confidence intervals, and campaign cost. Revenue alone is insufficient, so I would include rewards expense, servicing cost, and customer value. I would examine results by segment to detect heterogeneous effects. If randomization is unavailable, I would use matching or difference in differences and clearly state the limitations. In your answer, cover treatment and control groups, randomization, retention definition, observation window, incremental lift, statistical significance, profitability, selection bias, and monitoring for unintended customer or risk outcomes. Question 9. What steps would you take to make a Tableau dashboard useful for executives? I would start by identifying the decisions executives need to make, then show a small set of clearly defined KPIs with targets and period comparisons. I would use a visual hierarchy, headline metrics first, drivers second, and drill down details last. Filters should be limited, intuitive, and consistent. I would annotate unusual movements and display data freshness. Before release, I would test performance, accessibility, and interpretation with business users so the dashboard supports action rather than passive reporting. Discuss audience and decisions, KPI definitions, visual hierarchy, filters, annotations, performance, accessibility, data freshness, drill down design, and avoiding charts that create misleading interpretations. Question 10. How would you design a Tableau dashboard to monitor fraud trends? I would show fraud rate, fraud value, transaction volume, approval rate, and false positive rate together because one metric can mislead. Trend lines would be segmented by product, channel, merchant category, geography, and authentication method. I would add a detail view for investigators and threshold-based alerts for sudden changes. Sensitive customer data would be masked, with access controlled by role. I would agree on definitions with fraud operations and validate dashboard numbers against the case management system. Be sure to mention fraud rate definitions, volume and value metrics, segmentation, geographic and temporal views, alert thresholds, privacy, refresh frequency, false positives, and balancing analyst usability with executive clarity. Question 11. Explain how you would choose between mean, median, and percentile for a business metric. I choose the statistic based on the distribution in the decision. Mean is useful for totals and stable, symmetric data, but large transactions can distort it. Median better represents a typical customer when spend is skewed. Percentiles reveal operational tales, such as the 95th percentile of dispute resolution time. I usually report multiple views when risk matters. Average value for financial planning and percentiles for customer experience. I always visualize the distribution before selecting a headline metric. Focus on distribution shape, outliers, skew, business interpretation, sample size, confidence, and examples such as transaction value, response time, income, or customer spending behavior. Question 12. How would you explain a complex analytics finding to a non-technical stakeholder? I would lead with the business implication. For example, approval rates fell mainly among online transactions after a rule change. Then I would show one simple chart, explain the comparison period, and quantify affected volume. I would avoid technical jargon but remain precise about confidence and limitations. I would recommend a reversible next step, such as testing a rule adjustment on a controlled segment. Finally, I would ask stakeholders whether the finding answers their decision need and refine the analysis accordingly. Mention starting with the business question, leading with impact, simplifying terminology, using one clear visual, stating confidence and limitations, recommending action, and checking understanding through stakeholder questions. Question 13. How would you calculate customer lifetime value for a card portfolio? I would define lifetime value as expected contribution margin over the customer relationship, including fees, interest, interchange, and relevant partner revenue, minus rewards, servicing, acquisition, and expected credit costs. I could estimate retention by cohort and discount future cash flows, or use a simpler segment-level model when data is limited. I would stress test assumptions around churn and spend. The results should support decisions such as acquisition budgets, but I would present ranges rather than false precision. Cover revenue components, costs, retention or churn, discounting, segmentation, assumptions, uncertainty, cohort analysis, and avoiding inflated value from counting revenue without rewards, servicing, credit, or acquisition costs. Question 14. What is cohort analysis, and how would you apply it to card member engagement? A cohort groups customers by a shared starting event, such as account opening month, so later behavior can be compared fairly. I would measure activation, purchase frequency, payment behavior, or retention at 30, 60, and 90 days after opening. This avoids confusing customer age with calendar seasonality. I would compare cohorts exposed to different onboarding experiences and investigate changes in their curves. The analysis could guide welcome campaigns, but I would still test whether improvements are causal. In your answer, explain cohort definition, consistent time periods, retention or usage curves, separating acquisition effects from seasonality, cohort comparison, and translating patterns into product or marketing decisions. Question 15. How would you detect and address outliers in transaction data? I would first visualize amounts by product, merchant category, and geography because a legitimate premium purchase may look abnormal globally. I could use IQR or robust Z-scores for exploratory detection, then compare flagged records with fraud labels and source system rules. I would not automatically remove them. Some are valuable fraud signals. For modeling, I might cap extreme values or use transformations, documenting the choice. I would separately correct impossible values caused by data errors and retain authentic high-risk events. Discuss business context, robust statistical methods, visualization, segment-specific thresholds, fraud versus data error distinctions, Windsorization or exclusion, and preserving outliers when they carry meaningful risk information. Question 16. How would you optimize a slow SQL query used by a recurring analytics report? I would reproduce the issue and inspect the execution plan rather than guessing. I would filter dates and statuses early, select only needed columns, verify join keys, and check for accidental many-to-many joins. Depending on the warehouse, I might use partition pruning, clustering, indexes, or a pre-aggregated table. I would compare runtime and resource usage before and after, then reconcile row counts and totals. A faster query is not successful if it silently changes business results. Be sure to cover query plans, selective filters, indexes or partitions, join cardinality, avoiding unnecessary columns, pre-aggregation, materialized views, statistics, and validating that optimization preserves metric definitions. Question 17. How would you build a simple model to predict customer churn using Python? I would define churn using a future inactivity window and build features only from information available before the prediction date. Useful inputs might include recency, spend trend, product usage, payment behavior, service contacts, and tenure. I would use a time-based train test split to prevent leakage, compare against a simple baseline, and evaluate precision, recall, lift, and calibration. I would explain drivers with interpretable methods and use predictions to prioritize outreach, not automatically deny services. Cover target definition, leakage prevention, feature engineering, temporal splitting, class imbalance, baseline comparison, evaluation metrics, explainability, and how predictions would support intervention without creating unfair customer treatment. Question 18. How would you handle an ambiguous business request from a stakeholder? I would restate the request as a decision problem and ask what action the analysis should enable. For example, which customers are valuable, could mean revenue, profit, retention, or strategic potential. I would agree on definitions, population, time period, granularity, deadline, and success criteria. Then I would inspect data availability and produce a small prototype or sample output. Confirming direction early prevents wasted work and creates shared ownership of assumptions and trade-offs. Mention clarifying the decision, metric definitions, scope, audience, deadline, data availability, success criteria, assumptions, and delivering an iterative prototype before investing in a large analytical solution. Question 19. How would you ensure analytical results are accurate and reproducible? I would document the metric definition, source tables, filters, joins, assumptions, and refresh schedule. My SQL and Python code would be version controlled, modular, and reviewed by another analyst. I would add tests for row counts, null rates, duplicate keys, date coverage, and reconciliation to trusted financial totals. I would record the analysis environment and parameter values so it can be rerun. Dashboards would show freshness and limitations, making governance part of delivery rather than an afterthought. Focus on source validation, documented definitions, version-controlled code, modular transformations, automated tests, reconciliation checks, peer review, data lineage, refresh monitoring, and communicating known limitations to users. Question 20. Tell me about a time your analysis changed a business decision. In one project, a team planned a broad retention offer because overall engagement was declining. I analyzed customer cohorts and found the decline was concentrated in recently acquired digital customers, while long-tenured members remained stable. I presented the segment trend, estimated the avoidable cost, and recommended targeted onboarding instead of a portfolio-wide discount. The team piloted that approach, improving early activation while reducing incentive expense. I learned that clear segmentation can turn a vague problem into a focused, measurable decision. Prepare a concise star story covering the business problem, analytical method, stakeholder collaboration, quantified insight, recommendation, measurable outcome, and what you learned from feedback or implementation. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.